Welcome back to Switched to Linux. Well, today I want to have a brief talk about immutable operating systems because we have seen this mass proliferation of them. Now, are they all brand stinking new? No. But what happens in the world of marketing, for example, is there's this slow adoption phase, this very early adoption, which is very few people know about a product. Nobody really cares about it. So people who do hear about it, maybe they'll try it, maybe they won't. And then when you get this adoption curve, people start getting excited, and then you get this asymptote. And it's like, whoa, really exciting, and then everybody wants it, and then it levels out as basically everybody has it, and now all of your sales of the new product are either replacements or new people coming into the market. That really is what we see in pretty much the way any new product is distributed across the world. And so in the terms of Linux distributions, looking at immutable desktop systems, it's right at that part where it's starting to go up right now. They become this massive proliferation. As I look back just a few years ago, Fedora Silverblue really came out. I looked at this going, I don't really quite understand the purpose of this. Let's just ignore it for a while. And I did. I finally just got around to doing a Silverblue video just a couple weeks ago. First time I've looked at Silverblue. Of course, in this last month, though, I've also looked at NixOS, I've looked at Vanilla, I've downloaded a few other ones that I wanted to play around with as well, and so I've got a chance to play around with a few of these containerized systems, the immutable operating systems. So let's talk about what is it defined by, why is this an idea people are going with, and is this the future of the Linux desktop? So first, what is it? An immutable operating system is an operating system based on containerization. You effectively create a system image, and the idea is the core operating system itself doesn't change, and any packages you install do not make any lasting impact on the operating system. This is a divergence from Linux, where the dependencies, or what we might have called in the past dependency hell, which is what Flatpak snaps and app images are all seeking to solve in their own way. Instead of packaging all those dependents, throwing them into the core of the system, having this mishmash of weird dependencies, and then installing a package on top. That did make sense for a long time, and in all honesty, depending on your application, it might still make sense now. It takes a lot less space, and there's a few other moving parts with it that I do still like that model. It is still my preferred. I'm more inclined to install something out of the repository, utilizing core system dependencies, rather than installing a Flatpak, an app image, or a snap package. Now, with the immutable systems, all of the software is completely separate from the core operating system. Even if you are doing something through a repository, even that you're putting the dependencies inside of a container. We talked about that briefly in Vanilla OS and on the Fedora Silverblue video that I just did recently. Both of those we built up a little separate container, and then we installed packages inside of that container. In order to run those packages in that container, GUI or otherwise, you had to boot up the container first. So the idea is, first and foremost, it is a very secure way of doing things. This is basically like the image type system, like a Docker image. The idea is that the core operating system is completely different from all the software, and so what ends up happening is the software itself does not have any lasting impact in the operating system, and the operating system should not have any impacting on the software. What this means is that each of these can operate independently, and if you get malware in one sector, it doesn't affect the other. And so even the way malware works, unless it's containerized itself, it'll probably fizzle away, because even if you get root access to an immutable system, chances are you still can't make any changes to it because it's all an image. Now, NixOS is way more strict with this as I've looked at them. Fedora Silverblue, a little bit less strict. What do I mean? Fedora Silverblue, I can still edit the host's file. Nix, you can't. Every single change has to be done on that stupid configuration file. I gotta say, that's one of the big reasons I decided I just don't want to use it long term, because I am always having to make changes to my host file, we're working on development servers and things like that. And the idea of going into that giant configuration file and then just making those little tweaks and then having to swap the image of the system just to test something, it just makes me want to go and cry in a corner somewhere. So I don't really want to mess with that. If if I'm doing to do an immutable system on the Raspberry Pi in production, I want something that I can definitely edit that host file. The bare minimum. All right. The rest of the containerized stuff, we'll leave it. I don't care. Whatever else. So you have this benefit of security. You have this benefit where any changes to the system should not impact anything else. Whereas if you're doing a traditional Linux system, you update it and the update updates a dependency and the dependency causes a critical application to fail. Now you have to fight with that application to figure out how to make it all work with a new form of dependency. That is what the containerized system software or Core OS has in mind. So the idea that we have here with all of this is that the immutable operating systems, which are starting to proliferate out, these immutable operating systems do have a future in the world of desktop Linux. Now, usually you would deploy these in servers. This is why we're just starting to see them coming up in the desktop world, because in servers, you really do kind of want the containerization because it makes it easy to deploy things, take things down, update things, and then if you push an update and the whole thing crashes down, you don't have to worry about rolling back individual updates. You just revert the image. And that's how NixOS works. You look at that loading screen and you'll always see a few different NixOS versions. We have the current running and we have the backup staging. And there might even be more back there. Now, this does take a lot more disk space to do. That is a problem with it, especially since we've just had this shift where we went from hard drives that got up to massive sizes to SSDs, which started in smaller sizes. They are growing in size. I mean, I just bought a 1 terabyte SSD for $60, and so far the thing works great. We did a video on that. So we're seeing this, the spaces is starting to come back, but if you have to cut your core operating system down in half, at least we have, we're getting to the point where the size on our disks are becoming a little bit bigger. But the idea here is that the security model, the separate images, the fact that if you do happen to run malware in it, just like malware getting installed on a phone or on a router, reboot the system, malware goes away. We get the same system with an immutable operating system. It's basically an image. It's a static image. You boot the static image, and then what do you do for applications? The reason we didn't see these for a long time is the lower trust level on your 3-core packages, your snaps, your Flatpaks, and your app images. Now, as those are all really taking off and a lot more people are comfortable with one of those 3 at least, then you'll have the ability to have an immutable operating system where the applications themselves package everything you need inside of it all in one package. And so this is a really good thing. It's going to increase some desktop security. It's going to give us better application use. It's going to give us, in cases like app images, you can run multiple instances of app images with different versions. If you like this version for one application of your task and another version for another application of your task, you can run them concurrently if you want to. And we're seeing a little bit more of this ability. Why? Because all of the core is isolated from each other. Containerized systems are definitely a better security model. It makes more sense to use. So as we start seeing the containerization, we'll actually get a little bit better results in that sector. Now, here's my downside, and here's why I'm a Luddite, as you know. I don't like to necessarily embrace the new stuff as soon as it's around. The biggest concern I have is the loss of controlling and using and basically the full ownership of your system. Everything is tied into an image and you can't easily change that image. We start losing the ability to make changes and modifications to the systems that we want. And that kind of is a problematic thing. So that is really my big downside. Overall, though, I am going to be playing around with more of these. I might deploy some more of these. Overall, I'm not going to quickly just move everything over to immutable systems. Even my attempt to put my Raspberry Pi on an immutable system was met with more frustration than anything else at this point in time. So we'll see what happens with it down the road. If you guys want, I still will play around with that a little bit. I mean, I got the extra Raspberry Pis. Maybe I'll just dedicate one project to do on that and everything else on something else, see how it works. But anyway, those are my thoughts on the immutable operating systems, how they work, what they are, and hopefully you'll understand it. Stay tuned on the channel. We are going to have more, and then as the year progresses on, I'll do a roundup of what I consider to be the best immutable Linux distributions as I've played around with more of them. So let me know your thoughts on all those, and thanks for watching this video today, guys. Have a look down at the description in there. We have some links down there. Help support the channel with all that. With that, thank you for watching, and I hope that you enjoy switching to Linux.
Thank you for watching this video from Switched to Linux. This channel would not be possible without the backing of the program supporters scrolling on the screen now. You can be a supporter at Patreon at patreon.com/TOMM or at thinklifemedia.com. I also want to thank the open source community who creates such excellent software that makes producing this show possible. Please remember to support your software communities. Thank you, and I hope that you enjoy switching to Linux.